Oh, now it is. Now I got that thing. Okay. We are recording now, so welcome everybody to class. So let's see, what did I say at the beginning of class? I probably will. I got a few people who weren't in class yesterday and they tried to access the videos and it forced them to log in. Now, theoretically, actually, let me just throw this out there. For any of you who downloaded the Microsoft Teams app, first of all, who did that? Just say my name is, and I did that.
Alyssa did that.
Joshua did that.
Joshua did that. We'll pick Joshua since I heard that clearly. So, do you know, were you able to access the recording of the video? And did you log in?
Yesterday's recording?
Yeah.
I didn't even check.
Did you log into today to access Teams? Did you?
Yeah.
Did you use your UVU login?
No, I used my other Gmail.
Oh, you have a separate Gmail account?
Yeah.
All right. Well, here's what I will do. It will take me a little bit of time because I would have to rerender this. I can repost these on YouTube, and then you can access them the same way. It's just going to take me a little time every day. So anyway, for those of you who couldn't see yesterday's video or today's, I will download these and then upload them to YouTube so you can watch them. So I apologize for that. What was the other thing that I was going to say at the beginning of class? Does anybody remember? I had two announcements. That was one.
That you're going to give us extra credit and we no longer have class?
Well, we no longer have class except for at your home. But yeah. So anyway, I don't remember what it was, but it'll come up, I'm sure. Oh, I know what it was. It was the homework. Somebody said that the files got moved, and I did move that because I'm putting all the quiz files in there, and I didn't want people to access that. So if you want to access the homework, go to the syllabus, and it's all listed there, and you should be able to download it that way. That's what the other one was. So, all right. So we're going to start today on 6.2, which is the algebra of matrices. Okay. So this is actually, you're going to like this section, I think, because it's pretty easy. So if I had a matrix A, B, C, D, and I told you that it equaled 1, 3, 5, 2, it's probably pretty simple to say, well, A equals 1, B equals 3, C equals 5, D equals 2, right? That wouldn't be very hard, okay? So, so matrix addition, I bet you guys could figure this out. If I had a matrix A that was called 2, -3, 0, 5, and 7, -1. And I had matrix B, which equaled 1, 0, -3, 1, and 2, 2. And I told you I wanted you to add A plus B. I'll bet you guys could tell me what it is. So nobody's on camera, unlike my other class. And let's see, I'm going to pick on William. William, what do you think A plus B would equal?
I think A plus, so you add those two matrices, so
Right.
would think that it would be like 3, -3.
Yeah, 2 and 1 would be 3.
Yeah.
And then -3 and 0 is?
-3.
Okay. 0 and -3?
Another -3.
-3. 5 and 1?
6.
6, 7 and 2.
Or that would be 9.
9. And negative 1 and 2.
Just 1.
Okay.
Yeah.
So that's pretty easy, right? What if I asked you to, we're going to use the same two matrices, A and B, and I said A minus B. I'll bet you, Landon, you could figure that out.
Sorry, let me just unmute myself. So it's going to be 1,
2 minus 1 is 1.
and then negative 3.
Negative 3 minus 0 is negative 3.
Negative 3. And then 0 minus a negative 3 is going to be positive 3.
Okay.
And then 5 minus 1 is 4.
Okay.
And then 7 minus 2 is 5.
Okay.
And then negative 1 minus 2 is going to be negative 3.
Okay. Are you liking this so far? This is not too bad, right?
Oh, yeah. But we know what's
Okay.
coming.
Yeah. No, this section is not going to be too bad. You'll probably like it better than solving a 3x3 matrix. What if I said I wanted you to find 3A? So let's pick on Logan. What do you think 3A would be? Logan, you're on mute if you're talking.
Sorry, what was that?
If I wanted you to find 3A, what do you think that would equal?
You'd multiply the 3 through everything, right?
Exactly. So that would be
6,
6,
negative 18.
negative 9. 3 times
Oh,
3 is
what's
negative 9,
9?
right?
9,
3
0,
times 0, 0.
negative 15.
3 times 5 would be positive 15. You're probably having a hard time seeing my small thing. I wish I could make it full screen. I'm sorry.
Yeah, your thing is
wonder-
really small.
I wonder. No,
21.
that didn't help. Um, 3 times 7
21,
and 3 times negative 1.
3, negative
Negative
3.
3. Yeah, I don't know how to make this full screen unless, because I can't write on my tablet or on my laptop, so. But anyway, that's not too bad. So by the way, let me just refer to this one. This one has a special name, which is called scalar multiplication. Okay, which is basically just a constant times whatever the matrix is. Okay, so that one's pretty easy. Now, let's talk about properties. Sorry, this is properties of addition and scalar multiplication. I should warn you guys that we are going to multiply matrices together. That will be a lot more difficult than the scalar multiplication. Scalar is nice and easy, but so the properties, number 1, A plus B equals B plus A. Okay, so that's your commutative property. So the commutative property applies. Number 2.
Can you move the paper up a little bit?
Thank you.
Thank you.
Sorry about that. A plus B plus C equals A plus B plus C, which is your associative property. Okay, probably all learned these in elementary school and then forgot them. We also have, and this is where I have to get a little bit tricky here. Okay, so I hate using lower and uppercase letters, but if I have a lower c and a lower d and a capital A, so the capital letters refer to a matrix, lowercase letters refer to a scalar, like the number 3. So if you have a lowercase c times d times a, that equals c times d times a, okay? So that's also the associative property of scalar multiplication, okay? And then finally, if I have c, lowercase c, times capital A plus B, that equals lowercase c times A plus lowercase c times B, okay? That's your distributive property of scalar. This is hard to write. Multiplication. You should see my setup here so you guys aren't upside down. All right, so so all of those rules apply as you would normally think, okay? So if I had 2x, and x is going to represent a matrix X, minus A equals matrix B, okay? And if I had A equals 2, 3, negative 5, 1, and if I had B equals 4, negative 1, 1, and 3, and I said, in this case, solve for x, how would you do that? So let's pick on Enoki. What do you think? So let's first talk about this equation here, and then we'll talk about how it would work with the matrices. So Noki, can you hear me? Because you're still on mute. There you go.
Yeah. Can you hear me?
I can hear you. So let's talk about this equation first. How would you solve this equation?
Move over the A.
Move over the A. We're going to add A to both sides. So this is going to be 2x equals A plus B. And does it matter if I do B plus A or A plus B?
No.
Doesn't matter. Okay? Because of the commutative property up here. Okay? And then what?
And then you would solve A plus B.
No, let's get rid of the 2 first. How do we get rid of the 2?
Divide by 2.
Okay, so normally we would divide by 2, but let me just say one thing is we don't know how to divide by, we don't know how to do matrix division, but we do know how to do matrix scalar multiplication. So I'm going to multiply by a half, okay? So this is going to be multiplying by a half. And so that may sound like a silly thing, but you'll see why when I get into that matrix division or matrix multiplication, why that's an important thing. So x is going to equal 1/2 times A plus B. Okay. All right, so if we've got, so let's find A plus B first. What does A plus B equal in this case?
My screen's super light. I'm having.
Okay. So I'll help you out because I know these are hard to see. So 2 plus 4 is? We're adding just each of these elements. So 2 plus 4 is?
6.
6. 3 minus 1?
2.
Negative 5 plus 1?
Negative 4.
Negative 4. 1 plus 3?
4.
4. So this, oops, I didn't mean to make that a round. That's a matrix there. So that equals A plus B. Now we need to multiply it by a half. So 1/2 times 6 is?
3.
3. 1/2 times 2?
1.
1/2 times negative 4?
Negative 2.
And 1/2 times 4?
2.
2. Okay, so in this case, matrix X equals 3, 1, negative 2, 2. Okay, so
Sweet.
that's a little matrix algebra for you. Okay. All right, so now we've done all the easy stuff and has landed new. It never stays easy, does it? Okay, so now we are going to do matrix multiplication. Okay, as opposed to scalar multiplication that we did before. Okay, so now here's what we need to know. Okay, actually, let me just point this out. First of all, it is not commutative, which means, now commutative would mean, in fact, maybe I'll bring this back here for a second. Remember, in the case, commutative means you can switch the order and it doesn't matter, okay? This time, order matters a ton, okay? Now, you can only multiply let's see here. In fact, sometimes matrix multiplication, if you switch the order, it's not even possible, okay? So let's say that I have an n by k matrix. So this is rows, and this is columns, okay? So you've got a, let's say, for example, a 2 by 3 matrix, okay? And you can only multiply that if the columns of your so the columns of the first matrix are k, and the rows of the second matrix also has to be k. So for example, if I have a 2 by 3 matrix, I would have to multiply that times a 3 by, perhaps it doesn't, then this number's not going to matter. 3 by, say, 1. Okay, so k by, I need another letter, q. Okay, so in this case, the middle, so these two numbers here in the middle, they have to be the same. So if I had a 2 by 3 matrix, so 2 rows, so 1, 2, 3, 4, 5, 6, let's say. And I wanted to multiply that by a 3 by 1 matrix, so a 3 by 1, 3 rows. So that's going to be 0, 1, 2. Okay, so this is what we call a 2 by 3, and this is a 3 by 1. Okay, this is actually possible because these two numbers here are the same. Okay, now your resulting matrix is going to be these two outside numbers. So it's going to be 2 rows by 1 column. Okay, now this is kind of a weird one, and I kind of picked it on purpose so that you can see this. Okay, now, so first of all is matrix. So let me just mention this. Okay, if I tried to swap the order, okay, so I'm going to rewrite this up here, 0, 1, 2, and we're going to multiply that by 1, 2, 3, 4, 5, 6. Okay, this is a 3 by 1, 3, and it's always rows first, rows by columns. So 3 by 1 times a 2 by 3. Okay, these numbers are not even equal. The 1 and the 2 are not even equal. Okay, so it is not even possible, to reverse the order. Okay, now let me show you how this works. Okay, so basically what we're going to do is I'm going to take the first row and I'm going to multiply it by, in this case, the first column. Okay, and the way this works, so 1 times 0 is 0. And then I'm going to add 2 times 1 is 2. I should have given myself more room. And then I'm going to add 3 times 2 is 6. Okay, so in this case, I've got a 2 by 1 matrix. The first cell is going to be 8. Okay, now I'm going to take the bottom row, 4, 5, 6. I'm going to multiply it by 0, 1, 2. So 4 times 0 is 0. 5 times 1 is 5, and 6 times 2 is 12. So this is going to be 8 over 17. So it's a 2 by 1 matrix. Okay, so that's a little bit different, huh? Okay, so we'll do another one in just a minute, but I do want to talk about the properties. I got to remember, I don't want to be off screen. Properties of matrix multiplication. Okay. Now, the nice thing about this, rule number 1, is if I have a matrix A and I multiply it by matrices B and C, I can switch the order, okay, A times B times C. That's okay. So the associative property does apply. Number 2, if I have B plus C times A, that does equal BA plus CA, provided that that's possible. So the distributive rule also applies. Okay. So let's do one more of these, and I really wish I could make my screen bigger. All right, let's say that I have matrix A equals 1, 3, -1, and 0. And I want to multiply that by B, which is -1, 5, and 2 on the first row. And on the second row, 0, 4, and 7. Okay. Now the first question is, can I even multiply these together? So I'm going to pick on Breezy. Breezy, is it even possible to multiply these two matrices together? How would you know?
So the first one is a 2 by 2, right?
2 by 2, okay.
And then
The
the
second one
is a 2 by 3.
2 by 3. So is it possible to multiply these together?
Yes.
Yes, because these two
Those middle
middles
numbers
are
are
the same. Okay. And so what is my resulting matrix?
So you would do, the first one is going to be, you would do 1 by -1, which is -1.
You're jumping ahead. So before you do that, that is correct. But before you do that, I want to know how big my resulting matrix is.
Oh, it'll be a 2 by 3.
A 2 by 3. Perfect. Okay. So what I like to do is I like to put blanks here. Maybe I should go down here. So it's going to be 2 rows by 3 columns. I'm going to give myself lots of room so I don't run out of room like I did last time. Okay. So we're going to take this first row and we're going to multiply it by the first column. Okay. All right. So that works out to be what? So 1 times -1 is?
-1.
-1. 3 times 0?
Is 0.
So we add those together. Okay. Now we're going to do the first row times the second column. Okay. So 1 times 5?
5.
3 times 4?
Is 12.
We're going to add those together. And then we're going to do the first row times the third column. So 1 times 2?
Is 2.
2. 3 times 7?
Is 21.
21. Okay, I'm going to switch my color of pens. I don't know if you guys will even be able to tell the difference, but just in case you can. Now, we'll pick this bottom row and we'll multiply it by the first column. Okay, so I will pick on somebody different like Caitlin Janes. And I'm going to have you multiply the second row times the first column. So -1 times -1 is?
-1.
That's +1.
Oh.
Negative times a negative is a positive, right?
Oh, right.
And
Yeah.
then 0 times 0 is?
0.
0. Okay, now we're going to multiply it by the second column. So -1 times 5?
-5.
And 0 times 4?
0.
And then we'll do the third column, -1 times 2?
-2.
And 0 times 7?
0.
Okay. All right, so now we can just summarize here. My final answer is going to be -1. 5 and 12 is 17. 2 and 21 is 23. 1 and 0 is 1. -5 and 0 is -5. And -2 plus 0 is -2. And so that is matrix multiplication. Okay, does that make sense? Okay. Now, I think we're going to finish this section. All right, so how does this apply to what we did yesterday? You may be asking yourselves. Okay, so what if I had a matrix that looked like this? 1, -1, 3, and I had 1, 2, -2, and I had 3, -1, and 5. Okay, so that's one matrix. In fact, we might call that matrix A. Let's say that I had another matrix, X, Y, and Z. Let's pretend that that was matrix X. And then if I had a third matrix, 4, 10, and 14. Okay, I think one of my students, a couple of my students are here a little bit early. That's okay, they're my statistics students, but they can come if they want. All right, so now if we did, let's call this matrix B, okay? So I'm gonna pick on Josh Hogan. If you were to multiply these first two together, A times X, what would you end up with?
A times X would be like X. And then, is that what is that, a 4?
That's a Y.
Oh, it's a Y. Then -Y. And then a 3Z.
Plus 3Z. Okay. And if we said these were equal to, that would have to equal, in this case, it would take this equal the 4, right?
Yeah.
Okay. Now the second row
Would be X plus 2Y minus 2Z.
minus 2Z
Equals 10.
would equal 10. And the third row,
3X minus Y plus 5Z.
would equal
14.
14. So you can see we can use matrix algebra and we can get our original 3x3 or 3x4, I guess, in this case, equations. So that's pretty darn cool, huh? Cool if you're a math geek like me, right? All right, so, gosh, are we gonna be done early today? Yeah, I guess we didn't take a quiz. We'll be done a little early. So, all right, so that is section 6.2. And Do you guys have any questions on that? No questions? All right, so I'm going to work on your quiz. I have another class right now, my statistics class. So hopefully it'll be up in the next couple of hours. So your quiz tomorrow will be on section 6.2, and I will see you all tomorrow.
Thank you.
Thank you.
Thank you.
Yep.
Thank you.
Thank you.
Thank
Everyone
you.
have a
good
good
one.
day.
Yep, we'll see you.